this do now just reviews a key concept that we talked about the other day, which is molarity. We were talking about different ways in which concentration can be expressed. And in regard to concentration, we had said that there are a number of ways that concentration can be expressed, and this all fits into what we're talking about in regard to solutions for this chapter. So in your notes, as we said the other day, concentration very simply is a ratio between amount of solute and either the amount of solvent or the amount of solution. So in regard to molarity, we have the moles of the solute over the volume of the solution in liters, and it's the total volume of solution. And there is one little wording change I want to make on your classwork. I'll do that when we get there. Today what we're going to go over are some other ways in which concentration can be expressed. Pretty straightforward, very math-based. I think you'll be very successful with this if you put the practice in. In regard to molality, molality is a lowercase m. That's why I said don't use a lowercase m to represent moles, because it represents molality. Molality is moles of solute over the mass of the solvent in kilograms. So this is a ratio between how much solute you have and how much solvent you have. Which substance gets dissolved, the solute or solvent? Solute, like we talked about the other day. So here's a series of pretty straightforward questions. The first two are very similar. I'll do the first one with you. We can do the second one together, or you can try it. The third one's a little bit harder than what you would see, but I just want you to be comfortable manipulating variables. So in regard to molality, moles of solute per mass of solvent in kilograms. And remember that 1 kilogram is 1,000 grams. Most of you are good with these conversions. You want to calculate the molality, so that's what you're looking for, of a solution made by dissolving 63.9 grams of magnesium acetate in 300 grams of water. So that's what's given. Let's break this down so we can work through it. In this first molality-based problem, we're looking for the molality. The mass of the solute is 63.9 grams of magnesium acetate. And the mass of the solvent, which is water, and most things do dissolve in water, we talked about that the other day, is 3,000 grams. Now we know molality is moles of solute over the mass of solvent in kilograms, so we'll just put kilograms of solvent and keep it simple. Are we given moles of solute? No, but we're given mass, so we can do a conversion. Now be careful with acetate. It's commonly used because we know salts that contain acetate, with the exception of silver acetate, are water soluble. I usually write acetate this way because it comes from acetic acid, but it may be better to combine like terms, if you will, and have magnesium C2H3O2 2, just to count it up. and grams of the same. And I got a little squishy, so I'm going to put an arrow in. So we have 1 magnesium, 4 carbon, 6 hydrogen, 4 oxygen. And that's going to be 142.3924. And that's going to make 0.449 moles of magnesium acetate. Now they gave us grams of solvent, but we need kilograms. So what do we do there? Not multiply, but divide by 1,000. Move the decimal 3 to the left. And you can say M or moles per kilogram. Either one is fine. So we converted the mass of the solute to moles. Using formula mass, we converted the mass of solvent, which was in grams, to kilograms. We divided the two and we got the molality of that solution. And one of the reasons why we're going over different ways in which concentration can be expressed is that you use different concentration units to further analyze solutions in regard to their changes in boiling point, freezing point, etc. Pretty straightforward? You want to try 2 yourselves? All right, 2 is on the screen or in your notes. rest of you look like you're in very good shape. Just make sure you formula write lithium phosphate correctly. Say it again. The answer, you ready? All right, but now see if you're saying what and yours doesn't match. Look at yours carefully. Did you have the right formula mass? Did you formula write properly? Was your mole calculation correct? And one thing, I know this is going to sound mean, but I'm going to start to collect your completed classwork the day of the test. Because if I look at your classwork for the previous chapter, I know there was a lot of it, but some of those test questions really matched the classwork, and some of you told me that it matched the classwork, verbatim. So if you would do your classwork and then redo it before the test, you would be very successful.
For the other question, is it, do you want the
Number 3 is a little more difficult. I just want to set that up for you. This is your molality formula, and you can solve for moles of solute or molality or the mass of solvent. And in question number 3, it's asking for the mass of water, which is the solvent. So in number 3, we're going to be solving for the mass of solvent. We'll initially get kilograms, and then we'll convert to grams. So I'll walk you through here. Number 3 is a little trickier. I don't really think I'd give you this on the quiz. There's one on the classwork. But you should be able to do it. You want to calculate the mass of water in grams. You've got 121 grams of sodium carbonate. So that's the mass of the solute, and you want to generate a 0.713 molal solution. Yep. It'll come out in kilograms, and then you'll do a final conversion. We'll do it together. On number 3, we want to calculate the mass of water in grams. The mass of the solute is 121 grams of sodium carbonate. And the molality is 0.713. So in this particular situation, we have molality, which is moles of solute, over kilograms of solvent. So we've got to solve here. And something we've talked about previously is that you can interchange a numerator on one side of the equation with the denominator on the other side of the equation. Well, we were talking about that this morning as we walked in. Now, she did warn me that be careful there. Don't start interchanging things that are not interchangeable. If you don't understand this, you can cross-multiply and solve, and you'll get the same thing. So you have kilograms of solvent is equal to the moles of solute over the molality. And with units, you can follow through on that. You'll know if you set it up incorrectly because your units won't cancel appropriately. If you don't see it, you've got this times this is equal to this, and then you're solving for this, so you would divide by m. The mass of solute was given, so the first thing we want to do is convert that to moles. have 121 divided by 105.998, and that's 1.14 moles of solute. And what are we going to divide this by? The molality, 0.713 moles over kilograms. Now the units may be a little tricky for you. What you're looking at here is the moles cancel, and then you have 1 over 1 kilogram. So your unit here is kilograms at the end, and I can do that out in more detail if you're having difficulty following. But that's 1.60 kilograms, and then to convert to grams, we're going to multiply by 1,000. Now that's only 2 sig figs, so these are one of the rare instances, as we've seen previously, where you do need to put it into scientific notation, or you could have just multiplied this by 10 to the third, which may have been easier. In regard to these funky units, let's take a look at this. When the moles cancel, you're going to have 1 over 1 kilogram, and then you've got 1 times kilogram over 1, which is kilogram. So you'll know you set it up correctly if you follow through on your units. And this one would be a little bit tougher. In your classwork, I believe 6 through 10, we'll double check that at the end, corresponds with the molality type problems. So molality is another way in which you can express concentration. And we'll be using molality quite a bit when we get to colligative properties, which sound much worse than you think. We'll be talking about why salt water freezes at a lower temperature than water alone, why salt water boils at a higher temperature than water alone, and we'll prove it calculation-based and also conceptually. Okay, another way in which concentration can be expressed is mole fraction. Mole fraction's abbreviated with an X, and it's a ratio of either moles of solute to moles of solution, or moles of solvent to moles of solution, where moles of solution is the moles of solute plus the solvent. So there's going to be a lot going on here. You can calculate the mole fraction of solute. Here you'd have moles of solute in the numerator over moles of solution in the denominator. Mole fraction of solvent is moles of solvent over moles of solution. Let's take a look at this first example. We'll work it together. I'll have you try and work too, and then you'll have some practice time. It says calculate the mole fraction of the solute, what we're looking for in yellow. You've got 61.7 grams of barium nitrate. That's your solute, what you're dissolving, and you're dissolving it in 130 grams of water. Mole fraction of the solute will be moles of solute over moles of solution. The mass of the solute is given.
Is it other kilograms also?
No. No. No kilograms in this one, just moles. 61.7 grams of barium nitrate, and again, the formula writing, critical. I told you that earlier in the year. The mass of the solvent is 130 grams of water. So we need moles of solute, then we need moles of solution. What should we do? Convert mass to moles. So we're going to have 61.7 divided by 261.338. So we've got 0. Let me write solute actually, that may make it a little clearer. For the solute, we have 0.236 moles. And for the solvent, we have 7.22 moles of water. Now what? You have to put the solute over the solution. So how do we get the solution? Got to add them together. And this is the step that the kids often forget. Be very careful here. When you add, you maintain the least number of decimal places. SOLN for solution. Now you have a situation where you can find the mole fraction of the solute or the solvent. This one asks for the solute, so what are we going to divide? .236 moles of the solute over 7.46 moles of solution. And this will be a number less than 1, hence fraction. What's the unit? What's 3 over 3? What's moles over moles? Nothing. You have a unitless quantity. No unit for mole fraction because the moles cancel. Be very careful with the solution piece. That's the common error.
So, in the last step when we were plugging into the final equation after we found the solution, why did we plug in .236 instead of 7.2?
Had they asked for the mole fraction of the solvent, which they do in the next problem, you would have plugged in that piece.
Oh, okay.
So it depends what they asked for.
Okay.
And they had asked for the mole fraction of the solute right here.
Mm-hmm.
Okay, with that said, couple things. I would like you to try to, I'll work it out in a minute and I'll put it on the screen. In addition to doing number 2, on the classwork you got the other day, 3.3, you should have done through number 5. If you haven't, you really need to. And with what we talked about today, you should be able to complete 6 through 11. Have your notes out in front of you initially with your formulas, and then try and cover up your notes to make sure that you're doing it correctly. Tomorrow we'll get into dilute versus concentrated solutions. We'll talk about how to make solutions multiple ways. You'll have a mini lab on that so that you can get a better feel for how to make solutions. That will help you a lot. And then we'll start to get into solubility and the factors that affect solubility. And I just have to decide where your quiz will stop, and then we'll know how far we want to go, and then we'll announce your quiz date. It'll probably be next week. I'm thinking Wednesday, but it's not going to go in this quarter. Your mini lab, it has a little bit of a write-up to it, so I'm not sure that's going to go into this quarter. Lab 3.2 is graded. Most of you did extremely well on it. I'll get that in. Lab 3.3 I'll still work on today or tomorrow and get everything updated as well. Questions on molality or mole fraction? 2 simple formulas. Just really keep track of what goes where in your equation, and you should be very successful with it.